All right, the time has come to tie together what I've been talking about regarding research, issues in research, and let's talk about a real world example. And this is not an example of things done well. This is an example of things done poorly, and a good example of why we need the guidelines that we have and what can happen when we don't conduct sound research or ethical research. And this is a psychology class that I'm recording these videos for. This example is not from psychology, it's from medical research, biological research, all right, but it's certainly relevant, and it's the sort of thing that the sort of topics that many people are familiar with. It has to do with vaccinations. In recent years, vaccinations have been in the news. I think most people are familiar with vaccinations. I know students at my campus were required to get particular vaccinations to be able to sit in the classroom. So, it is a really nice example of something that many people have at least, they've heard of at least some element, some aspect of it. All right, and it's a good thing to point out that research in psychology has to follow the same ethical guidelines as research in other fields. As long as human participants are involved, there are certain things that everyone conducting research is expected to do. All right, so what's the specific example? We are going to talk about it's almost becoming the saga of research regarding the potential link between vaccines and autism. All right, when I teach an in-person class, I often will I'll say, okay, what have people heard? What do you know about this topic? And depending on the semester, depending on the students, sometimes I get more talkative students, and sometimes I just get a different mix of students. But I will get different sort of feedback, but often I will get some kind of a mixture where I might have some students say, oh, I heard vaccines are awful and they're full of toxins and that they can, they can give you brain damage. And then I'll get some other students that'll say things like, "Oh, actually, I heard that the research that supposedly showed that vaccines were harmful, that there's like problems with it or something like that." I'll get a mixture and then I'll get other students. They're like, "I don't know, I don't know. I don't pay attention to this," and that's okay too. All right. So, if you are not familiar, as long as vaccines have been around, there has been some Actually, let me pause 1 second. I could give you a whole class about what vaccines are, but let's just make sure we get the basics here. If you don't know what a vaccine is, a vaccination or a vaccine, this is something that you introduce into the body, often through an injection. There are other ways too, but often through an injection. That's where I think a lot of people have had that experience. It injects something into your body to boost your immune system. It's a form of immunization. Immunization is the process of becoming resistant to certain diseases. Well, one way to achieve immunization is through vaccinations. Vaccines generally work, and this is the very basic, simple description. If this was microbiology, you'd probably get a more in-depth description of how vaccines work. But they take a tiny amount of a disease-causing agent, often a weakened or dead version of that disease-causing agent, like a virus. They introduce it into the body, like through an injection, and what it does, it stimulates the production of antibodies in the immune system. Antibodies are the fighters. They're there to fight disease. And so you stimulate the production of antibodies, and the good thing about a vaccine is it puts such a tiny or weakened amount into you that you don't actually get sick. You don't get the disease, but your immune system still builds up the defense system. So then if you get exposed to the actual disease, you're better able to fight it. Now, one thing about vaccines is sometimes people will think that a vaccine guarantees that you don't get the disease. Not necessarily, but it greatly reduces your chances of getting the disease, and in many cases greatly reduces the severity of symptoms you get if you do get that disease. And this includes things like COVID-19, blanking out, sorry, I just hit this tripod. Measles, mumps and rubella, pertussis, which is also known as whooping cough, polio vaccine, hepatitis, chickenpox, also called varicella, or it might be varicella. All right, sorry if I mispronounced it either way. All right, but various diseases that you can be vaccinated against, and then you don't have to worry about getting the disease, or if you do get it, it's not as severe, it's not as life-threatening. And a lot of the stuff that we do vaccinate against, we vaccinate against them because there's a mortality rate there. There's a chance that it could do serious harm, even leading to death. And so, that's why we want to prevent them. It's not just, it's not just a minor activity to try to reduce the spread of that particular disease. So, as long as vaccines have been around, there's been at least some resistance. I mean, there's just always resistance to modern technology and medicine. That just kind of happens. But the anti-vaccination movement really took off in late 90s, early 2000s. A huge factor was an article published in a journal called The Lancet. It's a well-respected medical journal. It was published by a team of people. The main researcher, the first author listed, is a medical doctor named Andrew Wakefield. And this article was published in 1998. And it was a small study. There were 12 participants. And the short version of what was claimed in the article is that they concluded that the participants who they all had, they didn't use the word autism, I think pervasive developmental disorder, which, we're always changing our labels and things like that, but it used to be that autism was under the umbrella term pervasive developmental disorder. Now we've kind of changed our wording, and now we also are using the term autism spectrum disorder. And so if anybody is wondering, yes, we have updated and changed the labeling. All right, so at some point I might say, that the participants had autism, right? They said pervasive developmental disorder. All right, so he said these participants did not exhibit their symptoms of pervasive developmental disorder until after getting a specific vaccine, their measles, mumps, and rubella vaccine, the MMR vaccine. And so when people began to hear about this study, there was already an anti-vaccination movement, just sort of under the whole anti-modern medicine. We don't like chemicals. We like to treat things naturally, sort of thing. I am kind of simplifying a whole movement there, but there was already a movement, but this gave them more leverage, all right? Like, hey, there's scientific evidence now. Now we have scientific evidence that vaccines can do harm, that they can give you autism or give you pervasive developmental disorder. And so, people got upset. And, parents of children with autism, and by the way, I am a parent of a child with autism, so I can certainly relate. Parents of children with autism, they often were asking the question, why? Why does my child have this? It's not a very satisfying answer to hear, well, some kids just have autism. Sometimes people want to find a culprit. I have another relative with autism who their mom for the longest time wanted to say that it was something that happened during childbirth. They wanted to say that the incompetence of the person that delivered led to their child having autism. But realistically, some people have autism. And in my family, we now have enough family members with autism. It's pretty obvious. It's just something that's there in my family. But not everybody, is as accepting of that. And so, it gave people something to blame, like, hey, this is where my child's autism came from. It's from that vaccine. The vaccine gave them autism or activated autism or something like that. All right, now some very important issues. Okay, some important issues. You may remember, if you've been watching previous videos, you may remember that replication is an important step in scientific research. We have to report studies. We have to see, do we have a consensus? Do we find the same thing over and over again? Do we have consistent results? If vaccines are doing harm, researchers want to know. They say, hey, we want to know that so we can fix this problem, so we can stop giving them if they are indeed doing harm. So lots and lots of studies followed. My cat just made a guest appearance. Hey, dude. All right, so lots and lots of studies followed. Remember how the original study just had 12 participants? Larger studies, prospective studies. Now, you don't know that term probably because we have not gone over that. All right, a prospective study follows people over time and waits for change to happen rather than asking people about stuff in the past. All right, Wakefield's study was a prospective study. People had to, the parents and the participants had to report on things that had happened in their past. All right, so it's actually better if you do a prospective study. That way you're not going in with any bias. You can actually watch change as it happens. You just get more valid results with a prospective study. You had large scale prospective, another term for that is a longitudinal study. Large scale prospective longitudinal studies, and they were well funded. They were carried out in a variety of countries and settings by well-respected researchers, and no single study published in any peer-reviewed journal to the time of this recording has found any link between vaccines and autism. All right, that is a very important point. This study was never replicated. Every once in a while, I'll see somebody on social media say, "Oh no, I heard that this one study found that there is a link between vaccines and autism." When I do a search for the study that they say exists, I can't find any evidence of it in any peer-reviewed journal. All right, so people still have heard of the original. Even though in science, if we can't replicate an original, we don't trust it. The issue here is the general public had heard about this study. And also, it was made worse by the fact that celebrities got on board with this. You had some celebrities who were writing books and appearing on talk shows and stuff and talking about the dangers of vaccines. And these were probably well-intentioned celebrities thinking that they were, doing some good in the world. But, they lacked scientific training and they ended up spreading misinformation. Now, with the study. All right, we're first going to talk about problems with just the design of the study, and then we'll talk about some specific ethical issues with the study. All right, so first of all, I already mentioned small sample size. We like larger sample sizes because any individual differences and compounding variables, you have less influence from those sorts of things when you have larger sample sizes. That's a very, very short version of when I teach advanced statistics. I go into a much longer discussion of that one, but small sample size is not good for research. So he had a very small sample size. Generalizability is low with a small sample size. We talked about this when we talked about case studies in the case study video. You want to be able to apply your results outside of your study. The smaller your sample size, the less you're able to apply your results outside of your specific study. Another problem is that it lacked a control group. Remember in the video about the experimental design, we talked about having an experimental group and a control group. The control group is there to let you see, well, what happens if nothing happens? Ideally, you'd have one group of participants who got vaccines and one group who didn't get vaccines, and you'd see if there's a difference in their rates of developing autism or pervasive developmental disorders. He didn't have that, all right? So that's a problem with that original study. And then the researchers were non-blind. They were not blinded researchers. We've talked about this when we talked about observational research, naturalistic observation, and other types of observational research. You want anyone who's making sense of your data, anyone who is coding, rating, documenting your results, they should be blind to the study's intent and hypothesis and what you expect to find. That was not the case here. There were surgeons involved interpreting the results from the children. They knew what the purpose was. They knew what, their goal, their intent was. And so that's a huge problem. That introduces bias, and you don't want to have bias in your study. Now, ethically, what were some additional ethical problems? All right. I haven't mentioned this, so you don't know yet. It turns out that Wakefield had a conflict of interest. If you don't know what a conflict of interest is, that means that there's something about the study that if the results support your hypothesis, you gain something from it. The most common conflict of interest is you're going to get money from the results, being in a certain direction. In this case, Wakefield was being paid a lot of money by a law firm. It was a law firm who was trying to put together a class action lawsuit against vaccine manufacturers. So they were paying him money to conduct this research. Essentially, they wanted him to find evidence that vaccines were harmful. So he had financial motivation to support that particular hypothesis. The other thing that is another important thing is he misrepresented the recruitment of his participants. Originally he made it sound like his participants, they just showed up in a hospital and then got involved in his study. All 12 participants were recruited through negative MMR vaccine campaign events. They were already biased in that direction. All right, these were not just sort of blank slate participants that showed up for his study, and most of them were already contacts of the lawyer who was paying Wakefield. They were not recruited from the population, in a manner where you're trying to get a representative or a representative as possible sample. They were not recruited in that way. Let's see. The big one. Can't forget this one. The data was falsified. Things were changed in the records. Timelines were changed. Dates were changed. They actually are able to go into the medical records of these participants and see that a lot of the things that was reported to have shown up within days of their vaccine, they had these symptoms before getting the vaccine. All right, and there's evidence that Wakefield changed. He changed his data. He falsified. You're never allowed to do that in research. Never. That's one of the worst things you can do, is just straight make up data. But he did that essentially. All right, another big one. Remember how we talked about IRB approval? He claimed to have ethics board approval, but the hospital ethics board apparently never gave approval of the study. And this was a study that involved like invasive blood tests, like spinal tap sort of thing. And so apparently he did not have IRB approval. And some people, this is not in the textbook that I'm using, but some people have also pointed out that the invasive tests that they had to go through were also a type of harm, especially since he made stuff up anyway, that it was like harm where they didn't even use the real results. So there are a lot of problems with this particular study. All right. Now, sometimes I'll have students, they'll say, well, I still don't like vaccines. I could teach a whole class about vaccines. All right. This is about the specific Wakefield study and its impact, how it was a flawed study, how it's an example of how you shouldn't do science, and its impact. And I do want to point out that the original 1998 article has been retracted. That's when they unpublish an article, and he did lose his license. He still is kind of a celebrity, but he did lose his license. Now, another thing I want to point out, the lasting impact. Vaccine rates did start to go down after the publication of this study. We had outbreaks of diseases that we hadn't seen in ages, because a lot of parents were refusing not just the MMR vaccine, but also other vaccines too. So we had measles outbreaks that we hadn't seen in ages. We had whooping cough outbreaks that killed perfectly healthy infants, and it's a heartbreaking story when you think about it. But those sorts of things started happening. The mistrust of vaccines, a lot of people think that this can largely be traced back to this particular study. All right, so it's a good example of how not to do research and how poorly conducted research can have a huge impact on society.